Okay, everybody, we are live here today with our fourth episode of DocumentDB from the dining table. I'm your host, Chad Tyndall. I'm a senior NoSQL specialist solution architect, and I am joined by my co-host, Brian Hess, who is also a senior NoSQL specialist solution architect. And we're also joined by a couple of guests here, Joe Idziorik, who principal product manager for DocumentDB, as well as Andrew Whitaker, who's going to be talking later in the show about some new features that have come out. He's a principal engineer on the service as well. So we're happy to have these guests today. But first, before we dive in, Joe, we always got to have some words from our sponsor here. I don't know, Joe, if you have your mask. We're supposed to be safe and wear masks here. But there's been some big news on the service. Of course, we're going to be talking about a bunch of new stuff that came out. But bigger news even than that is Cobra Kai Season 3. Joe,
so good. I mean, yeah, the last episode of Season 2, boy. Oof.
Yeah, it's rough. The end of that was rough. I don't know. Have you made it through Season 3 much?
I'm working through it. I think I'm on episode 2 right now. But boy, it is compelling stuff. Not even joking. Like it's cheeky, but it's compelling.
I know it's a sort of nostalgic thing that's supposed to be kind of cheesy, but I honestly think this is probably one of the best episodes, best seasons of TV I've watched in the last year at least. I mean, I'm not going to compare it to Game of Thrones or anything like that, but it's very good.
Glad there are sponsors. I'm glad there are sponsors. It just kind of makes it easy. Easy.
It's good stuff. It's good stuff. All right. Well, let's jump right in. We always start with a quick intro to the service for any viewers who are new to our Twitch show. And so, we don't spend too much time on it, but just if you're new to the service or new to the Twitch show, just give you a quick overview of DocumentDB, which is our fast, scalable, and fully managed MongoDB compatible database service. Of course, at AWS, our platform has many different purpose-built databases, and this is our MongoDB compatible document service. It's nice because it has fully managed. You don't have to do any hardware provisioning. All the patching happens automatically for you. Backups are automatic. The setup is quick. You don't have to go deploy any servers or anything like that. It's ultra scalable because of the way that we've decoupled compute and storage. So you're able to scale up your compute instances if you need more of those to service more queries. You're able to scale up your storage if you just need a lot of data, and you can scale those independently very quickly. So it is fast. You can handle millions of reads per second. And of course, we are compatible with now. One of the big announcements we're going to be talking about is our new compatibility for 4.0, but we are compatible with both MongoDB 3.6 and 4.0. So you use the same tools, same drivers, same command line interface, all of that, just to talk to the service. Joe, anything you want to add on that?
No, exactly. I think that's a good setup. I think it's a good parlay into a little bit more detail about what exactly does that 4.0 mean, and what was in that release, and what else we've been doing the last, I don't know, maybe 6 weeks since we were last on the air. I think we took a little hiatus there for the multi-week Reinvent and holiday season, but no, I'd love to talk a little bit more about what we did in 4.0.
All right. Well, yeah, so I think for people who want to learn a little bit more about the service, there are a bunch of different videos that you can catch up on from Reinvent. Of course, Reinvent ended recently here. That URL at the top, reinvent.awsevents.com, is still live. You can go register for free and watch any of the replays of any session, really, but there are a few good sessions from Amazon DocumentDB, of course, a deep dive into the service. We have a customer, Zulily, talking about how they use DocumentDB. There's migration is always a big topic of people coming over from other databases to DocumentDB. And of course, our co-host Brian did a really nice session about what's new in DocumentDB, which we'll be touching on today as well. And there are a bunch of other presentations from last year's Reinvent as well with links here. We'll post these slides up, and if anybody needs that, you can do that, or you can just Google DocumentDB Reinvent recap. All right, so of course there is a bunch of new product releases. Joe, this is what we kind of want to go deep with you about. The biggest one being adding support for MongoDB 4.0 API and the ability to do multi-document transactions, right?
Yeah, that was a really big one, Chad. I mean, you kind of look at databases, and a long time, I think people always kind of associated transactions with relational databases, and it turns out that transactions are a fairly useful concept regardless of kind of what your underlying data model is or pattern. When we launched DocumentDB, we launched it with 3.6 compatibility, and transactions came out in MongoDB 4.0. So in November 9th, a little bit about 2 months ago, we launched DocumentDB with support for MongoDB 4.0 compatibility, which means you can use your 4.0 drivers and tools in code with DocumentDB, but also the ability to do transactions, right? And transactions, using the same MongoDB API as folks use today to be able to really simplify the logic to be able to do multi-statement or multi-database or multi-collection operations, being able to do it under that nice umbrella of a transaction without having to do all kinds of fancy, complicated stuff outside of the database. And that's really what you want to use the database for, is to push that logic down into the database through a transaction. So that was one of huge customer ask. Really excited to get that into the hands of customers. We've been working really closely with quite a few customers, been having some really good success. So we're really excited for folks to continue to use and give feedback.
Yeah, that's great. And I know that transactions are of course, a huge and the biggest sort of spotlight for that big release. But if anybody goes and looks at the release notes, and you can Google DocumentDB release notes, find the page there, you'll see a laundry list of things that also came out at the same time that I didn't want to get lost in the noise is not the right word, but just lost in the fanfare of transactions, because the ability to use hints with find and modify, the ability to do covered queries where a find query with projection can be served directly from the index. I think that is a huge thing that, I know people use that a lot when they're using MongoDB. And so it's really nice to have that ability here with our product, as well as a bunch of new aggregation operators and some chain streams things as well. Yeah,
exactly. I think, and I think the really great thing is these are things that we've learned from customers and been working backwards. Like you talked about covered queries, not having to go down, being able to serve, a query directly from an index that's in memory versus having to go, scan pages in the heap is, significant performance improvements. We also added the ability to do indexing with the dollar lookup aggregation stage, reduced index size. There's some other, performance optimizations to add to set. All the, some of my favorite operators that we support now, if null and replace root. And for these things that we're talking about now, Chad, actually we launched these both in 3.6 and 4.0. So if you're using 3.6 today as a customer, you're just going to get these, automatically. And they're also in 4.0 as well. A few of the other areas which were some of the stuff I really liked in addition to this was the change streams, the improvements we made to change streams. We made those in both 3.6 and 4.0 as well, is you can watch now at an entire cluster level. You can watch now at a database level, and before you could always do it at a collection level. You can also specify the start time that you want to start watching at versus the last known token. And also increase your retention period to 7 days. So there's a lot of really goodness around there that makes change, being able to use change streams a much more, I'd say a much more robust way within your database to kind of meet your needs versus having, especially if you want to open up at a database versus having to open up a change stream at multiple different clusters.
Yeah, that's very nice.
Yeah, and so and all this stuff is just stuff we're working backwards from customers they've asked us to build. So I mean, that's what really makes this fun is this isn't Joe's opinion or Brian or Andrew's opinion. This is stuff that our customers want us to build. Some of the other stuff that we added in here, I also wanted a note for this launch, or between last time we talked and this time, is we now support, or DMS now supports, so the database migration service also supports DocumentDB 3.6 as a source. It always supported 3.6 as a target, but it supports DocumentDB 4.0 as a source and a target as well. So we added a bunch of functionality into DMS and a partner with that team to make it easier to migrate to DocumentDB depending on what version you're on as a customer. And we also launched into Sao Paulo in South America, which was a really big customer ask, and the Ningxia region in China. So we've been pretty busy here since we last talked. I think we've had, I don't know, six to eight launches in between, November and now, which the team's been really busy. There's a bunch of more stuff in the queue as well.
Yeah, obviously Reinvent time is when a lot of the huge launches come out, but I think the fact that we're opening up in all these other regions just speaks to the customer interest, and I know that there's just emails and requests coming in all the time. When are we going to be in this region? When are we going to be in that region? And I think it's great. It means that people are using it, and they want to use more of it in different parts of the world. So that's really nice.
Yeah, we're really excited. And, I think one of the big open questions is, hey, are we going to rev the engine from 3.6 to 4.0 and beyond? And absolutely. And we've been talking about this with customers for a long time, and we're going to continue to listen to customers. And if they want 4.2 or 4.4 or other capabilities, we're always going to work backwards from our customers and deliver the things that they want and need. 4.0 and transactions is a really big ask on the list, so that's something that we prioritized very highly last year, and very excited to get that out as a pre-event or pre-Reinvent announcement, so that folks could start using that. And we had a really big gaming customer within 3 days get through a POC and move on to production shortly after that. So we're really encouraged by the really early feedback that we've gotten from our customers. And it's been really fun. I mean, transactions are just such a fun project to work on, just because it's such a technically complex thing in the database, but such a powerful thing for developers. It just really simplifies everything. So we're looking forward to folks trying that out and giving us feedback.
Yeah, hugely complex. I know Andrew's going to drill down deeper into that here in a few minutes. Joe, I understand that there's a change happening here.
There is, my friends.
What can you tell us?
Well, I've been with the DocumentDB team for quite a long time, many years, and it's been one of the highlights of my career, and it's been great to see it launch. But moving on to other challenges within AWS, I'm going to be working on the Glue Elastic View service moving forward now. So still going to be around, and you'll still see me very much associated with DocumentDB, as I don't think I'll ever, the ownership principle is still extremely strong with me in the service. And I mean, obviously, Chad, Andrew, and Brian, we still talk a lot, and I still talk a lot with the folks on the team. But day-to-day operations, I'll be, moving over to Elastic Views. And for folks that don't know what that is, it's a new service that we announced at Reinvent that makes it really easy to be able to, replicate and combine in the future, join data between multiple purpose-built AWS services. So if you wanted to be able to, just one, few clicks from DocumentDB into Elasticsearch without having to write any code or set up any pipelines, it makes it really easy to be able to do that. And in the future, we're really looking at capabilities of being able to, join between tables. Imagine being able to do a join between two DynamoDB tables and write that output into Redshift just using a SQL statement, or being able to summarize data in one DynamoDB table and write it to another DynamoDB table, all with the fully managed serverless and without having to deploy or operate any code to do that. So that's what I'll be working on moving forward.
Yeah, the movement of data between all these different purpose-built databases is always something complex and hard, and people have to build custom pipelines and stuff for ETL. So having a really nice service to handle that will be great. Of course, your stalwart leadership of the service will be missed, but I understand that you have this call towards the chaos of launching new services and a little bit of a masochistic streak there, perhaps.
It is
a lot of fun. It's always fun and never boring, I'm sure.
Indeed, yeah, and looking forward to being on the show again when we when we have support for DocumentDB in the future, or whenever the need calls. But just want to thank Chad for the opportunity to be on the show and talk with folks, and for organizing, and looking forward to the continued success of DocumentDB.
Well, it's kind of like once you're a senator, you're always allowed on the Senate floor. So, once you're a co-host, you're always allowed back. So we'll have you anytime. It's been a pleasure.
All right.
Good luck with the new service.
All right. Well, thank you, folks. Appreciate it.
Thanks, Joe. Okay, bye-bye. All right. Well, that was Joe here. We're moving on. Brian's going to take over and talk about some stuff that he's done here with Sagemaker. So I'm going to bring in his desktop. And Brian, take us away.
All right, thanks, Chad. So, back in the fall, let's see when it was. It was, I think, back at, I had it right there. In November, launched this blog post around using DocumentDB and Sagemaker Notebooks, and so I thought I'd just kind of highlight this. It's an interesting piece that I bumped into when trying to kind of get started here. I was working with somebody who was doing Sagemaker pieces and realized, that using Jupyter Notebooks is a pretty popular way for people in the Python world to connect to, to do their work in general. And I bumped into having to use that with DocumentDB and realized, in the getting started path that we've got, right? You can see this is part 4. The other tools that we sort of highlighted really focused on much more of the first two were really around using the Mongo shell. One was through EC2 and the other was through Cloud9. And the other one was to use Robo 3T, pretty popular third-party tool. This was just another one to see if folks who like that Python experience, the Jupyter experience, to do it. You don't need to actually then stand up anything in terms of your own machines. All the services you need are within AWS. So I figured I'd just walk through kind of the steps of this, and it's really walking through this blog post here that you can get to from our resources page, and just kind of show how we do things. So here I am in Sagemaker. The first thing that's kind of handy to do is to create what's called a life cycle configuration. So I've already created a notebook because things take a little bit of time, but I figured I'd walk through this part. All this is really going to do is basically install a few things that we're going to want to have on a regular basis, so that we can just go ahead and kind of leverage them regularly. So I'm just going to pop in here some stuff I've already copied. Basically, it's going to activate a particular Python environment. It's going to install PyMongo, which is what we're going to use to connect to DocumentDB. And then it's going to go get the PEM file that we need for connecting to DocumentDB. And so if we do this once and save this sort of lifecycle configuration, then when we can keep reusing it over and over again when we create the notebook, which is instances, which is kind of handy. I mentioned I already had one, but just so that you understand what's involved in doing this, you sort of create a name, you choose an instance type. You don't need anything too powerful necessarily because you're not doing a lot of work in the machine itself, but you do need some. So you choose, as powerful of a machine as you need. I'll stick with something pretty cheap. We're going to want to do this additional configurations to grab that lifecycle configuration that we just did. And then because Sagemaker Notebook sort of spins up a small instance in the back, you sort of need to tell it how much local space it needs. Again, we're not doing a lot of work if you think of this as almost a proxy for the Mongo shell. We're not going to be doing a lot of work in the notebook. So I'm just going to leave it at 5 gig, which is the default, but you could certainly go and do more than that. In the blog, I walk through using or creating a new role. I've already done that, so I may as well just use this role that I have already done. And then we're going to want to handle the network. So what's interesting, what you need to be a little bit aware of when using DocumentDB is that it's only visible within a VPC. So when we pair it with other services, we need those services to also be in that VPC as well. So the default for these Sagemaker notebooks is to be not in a VPC, but we're going to want to throw it into the VPC that we've created. I guess I didn't highlight this. I've already got a DocumentDB cluster going over here, this 4.0 cluster, and we can see that it's sitting in that VPC. So I'm going to choose the same VPC it's in. I'm going to choose the public subnet that I have in there so that I can get to it. And I'm going to choose a security group to put this in so that it would have access to DocumentDB, and I've already sort of set that up as well. Again, services, the blog goes through the details a little bit slower and more measured, and we can create these things. But the idea here is you've already got your DocumentDB cluster, and you want to you want to add this to that environment, and we just create the instance. Now, like I said, that will take a few minutes to run. I've already got this one here, and so if we click the open, I should just close those. We click the open Jupyter, we end up at this page where I've got a couple of different things I was doing with DocumentDB 4.0, and I'll just use this transactions notebook just as an example. Because we already have installed PyMongo, I can just go ahead and import that. There's a couple other things that I've imported just for for fun that will help us go through. So this is just a couple of imports, and here's where I've now put in the DocumentDB cluster that I want, and I'm going to input in my username, and I'll use getPass to put in my password so you don't have to see that. The location of the file is put here. It could just download it into that space in that lifecycle config, so we can just use that. The string that we're going to use is basically copied directly from from this connectivity string here. It's basically the same thing going on there. So we'll format it with the pieces that we want, and then we'll connect to it. And we'll just run a command to show that we've got connectivity. And then this is a silly little transactions, demo. So we just sort of put in some data, and now we see, we're off to the races, and there's not a lot to it there. So you can save these notebooks as you go. You can save it with the output. I like the notebooks for doing demos because it has a way to keep all the commands, and you just kind of go from one to the next. There's nice ways to see tables of output that are a little bit nicer than just text ASCII art kind of output. Jupyter, the Sagemaker notebook has a lot of the stuff set up for doing data analysis, so you can also tap into graphs and more fancy ways of presenting the data than just doing these tables. And kind of off to the races there. It's a full Python environment, and it was actually pretty handy for me getting started, and that was why I sort of wanted to share that blog post with folks on how to do that.
That's why I wanted to ask you. Is this something that you would recommend primarily people use for demos, or what really is the best?
I think that I think it's really basically for people who like using notebooks. This is just another option. I would say that most of the time I tend to do things through the Mongo shell because I just do interactive bits of queries here and there, and I don't need to save, the work. That said, I find myself frequently going, oh shoot, up arrow, up arrow, up arrow. Like, where did I find that command from before? And the notebook style allows for a lot more of a history, and you can kind of get back to it, and you save an entire set of commands as opposed to going through a Mongo shell and then like copying over the things you want into a notepad. So I'd say it's more for if this is your style of development, this is great. You don't have to go and stand up a whole bunch of things. You don't have to like create an EC2 instance and install Jupyter and run that and connect. We have those tools already in AWS. I also think the other one that I would say is this is also a really good one for giving out for exercises. If you're going to put together some kind of a class or a training or a demo that you want to hand to somebody else where they run commands, instead of having a a Word document where you ask people to cut and paste from the Word document into the Mongo shell. And then you have to worry about Microsoft changing single quotes to the weird quotes, and they don't paste in right, and then you get these errors and whatever. I find that the notebook is a really nice way of doing an example or a demo for people that they can share, because it's got the code already in it. And we're not really asking people to the cut and paste is pretty benign. You're not having to do a lot of work, so why not just have them run the cell? And then of course they could muck around with it, right? This example gave everybody $1,000. What if I gave Andy $10,000 and I'll just rerun the cell? I can kind of iterate and start to learn by just modifying what I've got. So to me, that's the value of the notebooks. I mean, like I said, it's not my primary mode of operation, but I do know a lot of people who love them. And if folks really like that environment, then this is a handy way to bring that environment to DocumentDB.
Yeah, I know you guys have been working on a bunch of different training modules and immersion day content and things like that for training customers on how to use this stuff. Is this something that'll play a prominent role in those modules?
I'm not sure yet, actually, to be honest. We created the immersion day modules without, sort of prior to sort of exploring all these other services, and we stuck with a very basic shell interaction. But I could see, more advanced sort of modules that we want to go through to really kind of leverage this. I mean, one of the benefits of the Mongo shell is that anybody who's used Mongo is really familiar with it. And so I think we were dialing in on a lot of people already knowing Mongo. And Mongo and JavaScript is pretty common together. Mongo shell is JavaScript. This is Python. So there, I think Python is also used an awful lot with Mongo and DocumentDB. But this isn't really the JavaScript environment. So, I think we'll use it when it makes sense to use it. But I've been focused a lot recently on looking at DocumentDB plus other services and some quick wins. And this just seemed like a nice quick win for a pretty simple use case.
Cool. Yeah, I have used this with Neptune before, but I haven't used it with DocumentDB. And
yeah,
it is nice, the idea of having just a consistent user interface for interacting with any of our databases is just a really cool idea.
Yeah, I liked it. So it was I started over the summer, so I'm still learning things in the AWS environment, and I sort of share them as I find them, because we got a lot of folks who are new to DocumentDB, and it's a pretty fast-growing service, and so let's kind of meet them where they are.
Awesome. Good. Well, thanks, Brian, for that. And I'm gonna take this screen off. But can you post in the chat that blog post link so people?
You bet. Absolutely.
All right. Well, let's go ahead and bring in Andrew Whitaker here. He is our principal engineer on the back end of the service. He's one of the main men responsible for making this whole thing possible. Without him, we would not be here talking today. Thanks, Andrew, for being our special guest for this first episode of the new year. We're excited to have you.
Thank you, Chad. Those statements are not true, but I need the self-esteem boost, so I appreciate it. Thank you.
Well, we always want to make our guests feel good about themselves, so let's bring your desktop up. I don't know if you
got
want to present it or whatever.
Lost my desktop here. I got Windows on top of Windows. Here we go. All right. Cool. Yeah. Got it. Yeah, I've just prepared a few. Not a big slide guy, but given the forum here, it seemed sensible to kind of put together a little bit of material. So I'll kind of walk through this here, and really just kind of, we don't have a huge amount of time, but just kind of a couple of things I wanted to touch on. First, kind of the why, like, what are the use cases for transactions? When would you use one? And then, a little bit, time permitting, of sort of, implementation details, kind of what's under the hood here. So, and then from that, there'll be some implications for application design. And we'll see how far we get.
Yeah, our viewers definitely like that sort of behind the scenes secret sauce. Anything that we can give. I know we probably can't say everything, but whatever you could share is always.
Well, we'll see. We'll share some stuff. If we get in trouble, they'll come yell at me. But no, I think we can certainly give some interesting some interesting insight here. So, and then, yeah, obviously, if there's questions or comments, yeah, just kind of send them along. Happy to go off script here. That's probably more interesting than me kind of rattling off some slides. So happy to take questions or comments here. So cool. So I assume most people have, if you've worked with databases, you've probably encountered the concept of a transaction. It's not something that is completely foreign to you, but just to kind of level set here, maybe we could kind of start with the kind of basic introduction. A transaction, when I think of a transaction, I'm talking about sort of a sequence of database actions that execute atomically, and atomically is kind of one of these overloaded words. It means different things to different people, but really we kind of mean something that happens at a particular point in time, and maybe a couple of sub-properties there. So one is what database people call isolation. So what that means is if you have transactions that are running concurrently, they shouldn't interfere with each other, right? So transactions A and B, either A executes before B or B executes before A, but you don't want some weird mix where A is commingled with B, and the result is some arbitrary interleaving of those operations. So isolation really kind of means sequenced or serialized. Sometimes I sort of think of it as being sort of single threaded, like one transaction after another, and as a result, the transactions don't interfere with each other. The other property that's sort of fundamental to transactions is this all or nothing property, right? So if a transaction commits, then all of its effects are made permanent. Otherwise, there's no effect at all, right? So there's no way, you should never be able to observe a partially committed transaction, whether because of how the threads were scheduled, or because of a crash and restart, or even a hard drive failure. Like there's no event that should cause you to observe a partially written transaction. That's called a dirty read in the transaction lingo, and some systems would allow dirty reads, but DocumentDB is not such a system. So if you use DocumentDB transactions, there's no way you would ever be able to observe a dirty read or the effect of a transaction that is not yet committed. Okay.
Yeah. So that is a difference between, say, DynamoDB and DocumentDB, where in DynamoDB, if we're doing a table scan, it's possible to see parts of the transaction that have already been read committed.
Yeah, that's right. So yeah, Dynamo chose that, like scans, as I recall correctly, are not transactional. And so, yeah, there is no way to sort of take a transactionally consistent, scan or snapshot read. And they may, fix that in a future release. It's not a major part of their, they felt that was reasonable for what their customers needed. But yeah, DocumentDB transactions are a little more classic in the sense of like, they really are transactional. Anything that's part of a transaction will have the transactional guarantees. And the guarantees actually apply outside of transactions too, right? So to your point, Chad. So if I have a transaction that's doing a bunch of updates, and then I do a find operation, even if that find isn't part of a transaction per se, under the covers, it kind of implicitly is, or it is implicitly a transaction under the covers. So even if you're doing, sort of old school find operations, each statement in, each CRUD operation is itself sort of a mini one-shot transaction in DocumentDB, and it would have sort of all these same guarantees. So a regular find would also have, you wouldn't have dirty reads inside of a regular find, whether it's part of a 4.0 transaction or not. So thanks, Chad. That's a good point. So yeah, sometimes what people do is they kind of walk through the ACID acronym, AACID, and then you get these sort of arcane discussions of what the different letters in ACID mean. I think it's usually more productive just to kind of look at a few scenarios where transactions are particularly useful, just to kind of build up your intuition for if I'm in a situation like this, is the transaction the right hammer for my nail? So one sort of classic scenario or problem scenario is what's sometimes called lost update, right? So what this means is you've got multiple threads or multiple clients that are trying to update the same document. And as a result, they can end up clobbering each other, and one of those updates or several of those updates getting lost. So so this example is a bit contrived, but it's 8:30 in the morning here in the Pacific time zone, and I'm only on 1 cup of coffee, so you'll forgive me here. So that the example is we want to give Alice a raise, but for some reason we want to give Alice a raise that is 10% of Bob's salary. So don't ask me why, but that's what we want to do, right? So we need to query Alice. Alice makes X dollars. We need to query Bob. He makes Y dollars, and then we're going to update Alice based on this math here. So Alice gets 10% of Bob's salary, and then we're going to finally do the update in the last operation here. So we're going to do an update 1 with a dollar set. Okay, and so unless I've made a syntax error, this would be correct if, well, 2 things were true. 1, if there was no concurrency in the system, this was the only worker in the system. Well, actually, there's only 1 update here, right? So even if I crashed, I would have the all or nothing property here because there's only 1 update, and that update 1 is implicitly all or nothing. However, if there was concurrency here, we can get in trouble, right? If there were 2 threads that were trying to run this worker, or someone else was trying to update Alice's salary for some reason, then those 2 updates could clobber each other, right? So one sort of symptom or kind of template of this problem is you're doing some reads and then you're doing a write, and the write is a dollar set, right? So dollar set will just clobber whatever is there, right? So if this had been an increment or a multiply or something that was applied as a delta on top of the current value, then that would be fine. But here we've done some reads, we've done a write, it's a clobbering write, it's a dollar set, so it's just going to blow away whatever was there, right? So this would be unsafe if there was any level of concurrency in the system. Okay, so the answer, of course, is just to wrap this whole thing in a transaction. This is how this would look sort of in the PyMongo SDK. I won't go too deep here, just this is sort of standard, PyMongo syntax. The kind of best way to do this is to wrap this in what they use is this callback API. So you would create a session object, and then you would create a transaction within that session, and then you would specify the body of that transaction. What I'm calling TX1 here is the body of the transaction. So TX1 is really the whole transaction, and you're not seeing the begin and the commit. That's all kind of handled implicitly here. And this form is pretty nice because if there can be some what they call transient transaction errors. And if those transient errors happen, often just retrying the transaction will make them go away. So for example, transactions can get into deadlocks or lock timeouts or other sorts of transient issues, meaning that if we just retry the transaction, there's a good chance it will succeed. So if you use this sort of callback strategy, it will, A, you end up writing less kind of boilerplate code, and B, it handles a bunch of that like retry tomfoolery. So if these transient conditions occur, the SDK, the driver will automate a bunch of that stuff away.
I have a couple of questions here. So
yeah.
while this transaction is going on, what happens if another thread in the background is trying to change Bob's salary? Is that sort of update held off and locked out while this transaction runs?
Yeah, that's going to get us. I'll table part of that because it's going to get into some of the under the covers stuff. But yeah, what's effectively happening is the reads use what's called snapshot isolation. So when you start the transaction, you're essentially freezing your view of the database. So any read you would do would be based on the state of the database when that transaction started, or technically at the first read. But whatever, like when the transaction started, you've essentially frozen time, and all reads will reflect that snapshot. So then other transactions can update Bob in the background, and that's fine. They won't block. The reader won't block. The writer won't block. You won't get the update. You'll see the old version of Bob's salary, but you won't get any sort of blocking or deadlocks or any other sort of bad concurrency effects.
It's so interesting to see how different databases approach this idea of transactions. I know when DynamoDB added transactions, they also added this idea of an item potency token, so that if you do end up needing to retry the transaction, you don't increment Alice's salary twice by accident because of a retry mechanism.
Correct.
Is there any way to handle that scenario here as well, or how does that fit in?
Well, I mean, often it would just happen in this retry loop, right? So the what would happen? So the way that might work, so if there was, so what happens if two threads were updating Alice? Well, what you would get is essentially it would, so snapshot isolation wouldn't allow that, right? So you can't have concurrent writers. So if two threads were both executing TX1, they would both try to update Alice. One of them would succeed. One of them would, first lock on the document. You can't have write conflict. So one of them would try to take a write lock on Alice's document. The first thread would successfully take the lock. Obviously, the second thread would lose. Once the lock was released, it would observe that, hey, Alice has changed. So when I first read Alice's salary, it was version 1. Now it's version 2, and that's bad because that implies there's some concurrency there. And so as a result, the transaction would abort. And I believe those aborts are retriable. They're they're in the transient category, right? So as by virtue of using this sort of callback mechanism, those sort of transient conditions would just be retried. So effectively, there is an item potency token or the equivalent thereof. And if you use this callback strategy, all that would just be taken care of. You wouldn't have to think about the retries. It's handled by the SDK.
I think the case that we like to avoid is the scenario where our code, and just one executor here, not two, does the transaction. The transaction is committed, and so her salary goes up by some amount, and then before the service can reply, there's some sort of failure. Whether we don't know what that failure might be, but then the code might retry that again and basically double increment her salary. Is that a possibility, or is that
yeah, that's related to a copy. Yeah, I got it. Yeah, that's related to this like retriable write concept, which is something we don't currently support, although it is something we're kind of considering with a whole bunch of other feature requests. But yeah, that's sort of like item potent, sort of exactly once or at most once concept is really kind of captured by this notion of retriable writes in the Mongo API. That's their kind of general item potency mechanism. We don't support that today, Chad, but we certainly are considering it. And if people have a particular interest in that, we'd certainly be interested to hear about that and potentially prioritize that.
Awesome.
Give that a higher priority.
Awesome. Okay. Good to know. Thank you.
Yeah. No worries. So lost update, that's kind of a classic problem that transactions can help with. Another one is inconsistent read, and this is kind of related to the comment Chad had about scans in Dynamo. So the goal here is we want to maintain some invariant of the system, right? So if we were building our own virtual currency, maybe we've created 1 million virtual dollars in our virtual currency, and we want there to always be 1 million virtual dollars. Even if we transfer money between different accounts, money shouldn't appear or disappear by virtue of running what are effectively zero sum transactions between different accounts, right? But if we don't do these transfers as part of a transaction, then we can get an inconsistent read. We could view the system as having 1,050,000 virtual dollars or 1,000,000 minus 50 virtual dollars, right? If we can be in a transient state where the amount of money is not zero sum, it's sort of more or less than we would expect if the transactions were atomic, right? So in this case, well, there's a couple of problems here. So here I'm doing a transfer between Alice and Bob. So Alice is getting $50. Bob is losing $50, or he's transferring $50 to Alice. So sort of one obvious problem here is that I could crash in the middle of those two updates, and then we'd be in a limbo state. We permanently transferred $50 to Alice, and Bob never Bob never gave up his $50, so we, $50 was created out of thin air. Even if we could magically wish away that problem, like for some reason the transfer was always succeeded, we'd still have this problem with the second thread here, which is just trying to sum up the amount of salary in the system. And so we would, just doing a simple, this is basically a group by and a sum for you relational fans out there. And so this should always return $1 million or whatever amount I started with. But obviously I could end up with $1,050,000 or $1,000,000 minus 50 because there's no atomicity in the updates, right? So this is kind of a second class of problem, sometimes called inconsistent read, or I've heard this called read skew, or maybe some other names. So to reiterate Chad's point, yeah, we scans and aggregation pipeline operations, group bys, joins, sorting, everything in DocumentDB has sort of the same transactional guarantees. And those would apply even outside of transactions. So even if the updates were in a transaction and this aggregate wasn't in a transaction, it's all good. Any sort of single statement is implicitly a transaction, and you'd get the sort of ACID guarantees sort of regardless of whether you bundle them up in a 4.0 transaction or not. So you only really need an explicit transaction when you've got sort of multiple statements, right? So here, update one, those two statements need to be atomic. Therefore, I need to add some additional syntax there to make that a first class transaction. If you just have a single statement, those are always transactional in DocumentDB, which is a little bit different than, or very different than actually MongoDB. So if you do an update mini in MongoDB, you just like, hey, give every employee a 10% raise. That's not actually transactional in MongoDB. So that they're actually doing that in batches. And so as a result, if you crash in the middle of a big update like that, you're kind of in a limbo state. You may have done everybody, you may have done nobody, you may have done 30% of the database. It's actually kind of a bad situation. In DocumentDB, we made a different choice. So any sort of single statement is implicitly a transaction. So if you update every document in a collection, you'll either do 0 or you do 0% or 100%. You'll never get, something in between. So you're sort of getting implicit transaction behavior in any single statement. I don't think we've talked about that a huge amount publicly, but it is sort of part of the implementation currently. And I don't think we would change it, or I'm certain we wouldn't change it in a major release. So it is sort of something that you can probably build on. Cool. Just to go a little bit into the covers here, under the covers a little bit more. We don't have a huge amount of time, and you could give a whole semester class on database implementation, and we've got 10 or 12 minutes here. But I think we can kind of peel back the hood a little bit and get a sense of what DocumentDB is doing when you create a transaction, and therefore from there we can kind of glean some insights about what's the best way to use transactions in your applications. So if you sort of rewind time and look at how databases have been built in the past, you would sort of find two general strategies for transaction implementations. There's sort of lock-based implementations and multi-versioning, or sometimes called MVCC, multi-version concurrency control. And DocumentDB uses the latter, but we'll spend a quick slide here looking at lock-based, just because it's kind of helpful to understand why you would want to do multi-versioning in the first place. So lock-based, as the name implies, uses a bunch of locks to implement transactions. So transactions were first explored in the context of relational systems. And the way this would work is you'd sort of have, in the simplest form, is you'd have a lock with each, sort of row or tuple in the relational database, right? So if you did, and there'd be kind of read locks and write locks. So if you did a read on a row X or a document X, you would take a shared lock. And that just means, you can share the lock with other threads, but no one's allowed to write to it. And then if you need to do a write to it, you would obviously take a write lock, and that's exclusive. You can only have one writer. And then when you commit, you release all your locks. So under the covers, you're taking a whole bunch of locks. And because you're taking a whole bunch of locks, you can have deadlocks. So you gotta detect that and do something about it. And this approach works, and it's actually provable that you can get sort of serializable transactions out of this. There's really kind of a pretty elegant proof in the back of your transaction textbook. But the problem with these locks is they're locking, and so you can get lots of blocking operations. So any read would block a write, any write would block a write, any write would block a read. Everybody's blocking everybody else, except for reads don't block reads, but everything else is blocking, right? So you could imagine this could be bad, especially if you had sort of a long-lived read operation. Like I needed to sum up, do a sort of OLAP style query where I ran a 2-hour-long query that read every row or every document in my collection. That would take a whole bunch of read locks, and those read locks would prevent any updates from happening, and that would be undesirable. So what people quickly realized is, we wanted an alternative to taking all these locks and doing all this blocking. And that led to this idea called multiversion concurrency control. And just as the name suggests, what the trick we're going to play here is every time we do an update, we're actually going to create a new physical version of a logical document, right? So if you sort of imagine this sort of silly infinite loop over here, where I'm just updating a document ad infinitum over and over again. There's going to be a version where x is equal to 0. Then there's going to be a version where x is equal to 1, x is equal to 2, x is equal to 3. And you're actually literally going to get, k different versions. If you went to the disk that was storing the state for this collection, you would actually find, k different versions of this document coexisting. Like they're physically there. This isn't some like theoretical concept. There's actually, different physical versions. And this is advantageous because if you do a read transaction, you can just pick the version that existed when your transaction started. So if you started at time 0, you'd see, x equal to 0. If you did a read at time 2, you'd see x equal to 2. And the big benefit of this is that, you get rid of all the blocking. So the readers don't block writers, the writers don't block readers. Writers still block writers because you don't want, write-write conflicts. That's bad. But you get rid of all the read-write conflicts, and that turns out to be a huge win, especially if you're doing transactions that have any significant length. The bad side here is that now we've got a bunch of physical versions, and we can't let those, we've got a garbage collection problem. We don't want to let the number of versions grow into infinity. That wouldn't work, right? So just as in like Java or similar language, managed languages, they have a garbage collection problem. Usually garbage collection just works, but there is, it does create some potential for sort of bloat and some other considerations to be aware of. So, one implication of this sort of multi-versioning strategy is that it would be a bad idea to do transactions on large documents. So as a sort of contrived example here, let's say I was doing some sort of leaderboard or something where I had, users in my system, and there's some, metadata account or a score or something associated with these records. And then for some reason, I also wanted to store a JPEG or some sort of big binary image with each user. And a particularly bad design for transactions would be to throw the small data, the counter, in with the large data. And that is because if we did a transaction or even just a regular update of the counter, you're going to end up creating an entirely new version of this document, like physically copy it. And so the JPEG image would end up getting copied even if I just did an increment on the counter, okay? And that's obviously pretty undesirable. So a better design here is if you really do need to maintain, large datums in your database, you're better off splitting those into a separate collection and then, sort of tying them together with some sort of, pointer or foreign key. Probably best of all is just to kind of move the binary data into S3. Like that's a better system for maintaining this style of object data. But if for some reason you disregard that advice, at least make sure to kind of split them into kind of a separate collection, so you're not kind of creating these separate, multi-version copies.
Hey, Andrew, there's sort of two things that jump out at me with that, right? One of them is this concept that we've seen a bunch of people trying to put binary data like this JPEG data into, I'll say DocumentDB, but I mean, I came from other companies that have used different databases. I think putting those images into databases in general tends to be something that most databases say, put that in an object store and give us a link to it.
Yeah.
Just the more appropriate thing. So that's one comment here is that I think some of this bad design statement applies to not just DocumentDB and not just for this reason. The second thing was really this idea of data that changes and data that doesn't.
Yeah.
And splitting that out, right? This JPEG image, unless that's a picture where it's picture of the day, that's going to kind of stay my profile photo. You don't need to keep updating that. It makes sense to put that into a different collection that doesn't change, and again, make a link between them. And then you have the data that changes often. And if you can make the data that changes often relatively small, then to your points of this MVCC, those become much easier and manageable.
Yeah, I think that's absolutely, Brian. Thanks for rounding out the observation there. I think that makes a lot of sense. So yeah, to kind of generalize my point, yeah, I think you do have data that you've got data that changes frequently. You've got data that changes slowly, and so yeah, you can certainly optimize the system by sort of splitting those out. Now, I wouldn't go overboard. I wouldn't say like there's split every sort of logical document into 7 tranche. This is very frequent versus somewhat frequent versus rarely changing. You can go overboard and go nuts here. I mean, for things that are kind of simple structured data, integers and strings and the like, you don't want to outsmart yourself. So really, this thing, if you've got truly big data, that's where it's gonna pay off. But yeah, I absolutely agree, Brian, with your generalization of my comment. Thanks for the insight. The other kind of implication or thing to be aware of is that
Sorry, Andrew. Just we have a hard stop in about 2 minutes, so make this the last slide.
Sounds good. Well, so you can get bloating in garbage collection, any kind of garbage collection system. The thing that can exacerbate that are long transactions, because we won't garbage collect anything that's still visible. Now, today we have a 60-second timeout for transactions, so you can only accumulate so much bloat from a 4.0 transaction. However, as I said, any single statement's actually a transaction. So if you do a giant update or something, or a find that takes 2 hours, then that can lead to bloat in the system if you're doing a large number of updates. One thing that might not be obvious is that even queries on read replicas can contribute to bloat. Because of the way that replication works in the system, we can't reclaim old documents, even if they're visible on a read replica. What a few customers do is actually create, actual snapshots, restore from snapshot if you really need to do, very long-lived queries against a heavily updated system. That's perhaps not the cleanest user experience, but that is kind of one way to work around this bloat phenomenon. So, cool. People ask about performance. Performance is generally low and manageable. There's a fixed amount of overhead per transaction, but for realistic workloads, we haven't found it to be a major concern. Obviously, you should benchmark with your particular application, but I wouldn't rule out transactions out of some fear of a performance regression. It's generally low is what we've observed. So,
oh, that's good to know. Yeah, it's not like it's twice as long or anything like that. Because
as I said, under the covers, we're doing kind of one-shot transactions for everything. So it's not like there's some second mode of the system, like, oh, now you're using a transaction, and so we're in some completely different mode. Everything in DocumentDB has been transactional at the statement granularity. So there is a little bit of overhead just to kind of coordinate, do the batching and commit of a sequence of operations, but it is, it's an O1 cost, and it's not a night and day difference from what you'd get with just sort of vanilla CRUD operations. So
awesome. Well, that's I think we're out of time for today. So I want to thank our guest Andrew for coming and joining and diving deep into the new transaction feature. Obviously, that was a huge focus of the engineering team's work probably for the last year or so, at least. And a lot of customers are excited to have that. And also, I'd like to welcome again Brian as our new co-host to the show. Sad to see Joe leave, but happy to know that he's going to be working on something that's so important for the data services here at AWS, and happy to be working with Brian on this Twitch show. So thank you, everybody, for this. Thanks to everybody for joining today. And we'll see you in a month. The next episode is going to be February 18th. Same bat time, same bat channel. And yeah, we've moved to the monthly format for this show, which is great. And we'll see you in about a month. So thank you very much and have a nice day.
Cool. Thanks.